You've probably peeled a sticker or label without giving a second thought to the liner underneath. But in complex manufacturing, that thin backing can make or break your entire project. In this video, we'll explore 3 of the most common adhesive liner problems, how each issue can affect your process, and more importantly, how to fix them. 3 common issues with adhesive liners often stem from choosing the wrong liner type, having the wrong release strength, or using a liner with inappropriate thickness. Choosing the right material for your liner, primarily paper or film, is an important step in the converting process. Both materials have distinct advantages and limitations. Paper liners are cost-effective and easier to cut, but they are structurally weaker and more prone to tearing during die cutting. This can be especially problematic in high-speed converting or automated processes, where clean, consistent cuts are essential. Paper liners also generate more dust when cut, which can contaminate adhesive surfaces. This is a critical concern in industries like medical, electronics, or optics, where even small contaminants can compromise functionality. On the other hand, film liners offer higher durability and cleaner die cuts, which makes them a better fit for demanding environments. They are also more resistant to tearing and offer more flexibility in terms of coatings and thickness options. However, film liners are less compatible with standard printing methods, making it difficult to add registration marks or sensor indicators, which can be crucial to automated production lines. Having the wrong release strength is another critical variable. Release liners come in range of strength, easy, medium, or tight, and this impacts how much adhesion the liner has to other objects. If the release is too tight, parts may be difficult to remove manually or fail to release properly during automated assembly. This not only slows down the process, but can damage the parts or misalign them during application. If the release is too light, parts might fall off the liner prematurely, especially in automated process or during transit. Fortunately, the release level can often be tailored by selecting different coatings or liner constructions. And it's even possible to introduce features like tabs or folded liners to assist in manual handling while maintaining a tighter release where needed. The third major issue comes down to liner thickness, which plays a surprising role in both material handling and structural stability. A liner that is too thin might lack the stiffness needed to support the adhesive and part shape. As a result, parts might crumple and deform, making them more difficult to work with and potentially affecting their final performance. A thicker liner can offer the support needed for precise handling. However, excessive liner thickness may create issues as well as add an increased material cost. Another thickness issue that we have seen is uneven thickness. This is caused by deviations in the thickness of a liner. It can completely stop the converting process. Above all else, liners need to be consistent and the release value needs to be tailored to the application. To fix adhesive liner issues, the first step is to determine the desired release behavior. Automation will oftentimes require an easier release liner for the process to work correctly. However, most manual applications want the liner to stay on the part firmly until it is ready to be removed. Adjusting liner thickness can also improve part stability. In some cases, adding design features like tabs or folded liners can enhance usability, particularly in automated settings. The next steps in resolving adhesive liner challenges typically involve sample testing. Since choosing the right liner is rarely a one-size-fits-all decision, working with a converter like Strouse to prototype and test different liner types can lead to better informed decisions. Once you have identified the peel strength and thickness that best fits your project need, you can move forward with confidence in your adhesive's performance. If you're looking to learn more about making converted parts, you can visit our learning center for more videos and articles, or you can always reach out to us directly. Thanks for watching.